All right. Great. So today I want to tell you about one of my obsessions. Apparently, I have kind of an obsessive, what's it called, personality, and I mean that's either good or bad depending on how much I lean into it. But I'm kind of obsessed with itertools, and by the end of the talk, I hope you're maybe not obsessed with it, but at least much more interested in it than how much you are right now. So today, that's what I want to tell you about. And in this talk, I called it a tour of the module itertools, but this is actually part 2 because there's a lot of objects in the module itertools, and I'm not going to go through all of them. That would be an insanely long talk. And there's a talk I've given previously with the other half of the things we're not going to cover. Is it a terrible thing that you're watching part 2? No, this could be part 1 and the other one could be part 2. It's going to be the same. There's no dependency. Otherwise, I wouldn't be giving this talk to you, right? It would make no sense. Very well. So I want to tell you about itertools, but why would you care? Other than me being obsessed with it, why does my obsession matter to you, right? And it doesn't really. But the module itertools is relevant in and of itself. And I want to show you why. So I have on the screen 2 snippets of code. The range of 10 and the range of a gazillion, which doesn't even fit. You can see it's leaving the screen to the right. It's the range of a gazillion. Now the question for you is, which of these 2 snippets of code runs faster?
Runs means?
If you run them in the REPL, like if you type this in the REPL and press enter and you were timing how much time it takes to run both snippets separately, like would they run in the same time? Is one faster than the other?
Shouldn't it be the same time?
Yeah, it's going to be essentially the same time. Exactly. And from your reaction, I don't think you were not impressed by that. Excellent, because that's a great starting. If you're comfortable with the fact that these 2 ranges or these 2 snippets of code will run in approximately essentially the same amount of time, then you're good to go. Because the key realization here is that the built-in range generates elements on demand. So I see 6 of you in the room. Is anyone brave enough to do a very quick exercise with me? I need a brave volunteer. I promise it's going to be simple.
I have a computer open, so.
No. You don't even need a computer, Kushal. Thank you for volunteering.
Others, yes, please. Dietrich.
Everyone is so shy, except me, apparently. Yeah, let's go.
All right. So, what's your name?
Didrik.
Didrik?
Yeah.
All right, Didrik, I need your help.
Yes.
You're going to count to a gazillion.
Oh, okay.
Okay? But only...
Does it have to be accurate?
No, accurate enough, but you only count whenever I ask you for a number, all right?
Okay.
So, can you give me the first number?
Is it a 0 or a 1?
Let's start with 0 to match the range.
Yeah, 0.
Can you get me the next one?
1.
And the next one?
And a 2.
All right, thank you so much, Didrik. That's all I wanted. I appreciate your help. Was anyone impressed, not with the bravery, but with the fact that Didrik was able to count up to 2?
No one? Really?
No. Come on, folks. All right, no one is particularly impressed, even though in the beginning I asked you to count up to a gazillion, right? But because I'm only asking for a number at a time, you're essentially behaving like range. You only generate the numbers when they're needed. You didn't have to write down all of the numbers up to a gazillion to then start counting. That would be ridiculous. So you behaved essentially in a lazy way, in the good sense. And this is in opposition to something like a list, which would hold all numbers up to a gazillion in memory, and only then you would be able to work with a list. So this laziness, which is also kind of interactive, really is a key idea for the built-in range, for the built-in zip and enumerate, and for a lot of other tools in Python. And the reason laziness is key is because lazy iterables are awesome. And they're awesome because, okay, so I'm about to say a sentence. I studied maths, right? And mathematicians, they love to make statements that are true, but also completely useless. So lazy iterables are awesome because using a lazy iterable instead of something eager like a list has infinite potential upside. So you can make your code up to an arbitrarily large number times faster and more memory efficient by switching from an eager data structure to a lazy one. Now, is it always an infinite speed up? Of course not. It's always a finite factor, right? But like I said, I like to make statements that are true but also useless. But lazy iterables are awesome. And finally getting to itertools. Itertools loves iterables. When you're working with lazy iterables, because you get this benefit of the potential infinite upside, whatever I said earlier, you're losing some flexibility. There are some operations that things like lists can do, like slicing or indexing or reversing, that you don't necessarily have with general lazy iterables. So itertools provides tools to make it easier to work with iterables. Who could have guessed, right, from the name itertools? All right, is everyone with me so far?
Yes.
Excellent. So let's dive right into it. I brought a menu with everything that's available in the module itertools, but before I show you the menu, I have to say, I'm about to show you 20 objects, or at least the names of the objects. The objective is not for you to memorize them, unless you're crazy like me. But if you're a regular person, don't memorize them. That's not the point. The objective of this talk is to expose you to the type of tools, to the type of ideas that are available in the module itertools, so that the next time you need something vaguely similar, in your head, a light bulb goes on and you remember, wait, what was that thing that Rodrigo was rambling about the other day? And then you look it up and you get to use it. So that's the point, because once you're exposed to the ideas, it's easier to remember that there's something in itertools that you can import to help you out. Whereas if you have no idea what itertools does, this will never happen, because you can't know what you don't know. Right? It's another true statement that's completely useless. Great. So I said itertools has 20 tools. So naturally, I will fit them into 3 neat columns of 7 rows each. Is no one surprised that 7 times 3 gives 20 in this case? All right. So they're sorted alphabetically, and you're welcome. But this is kind of an information overload. So how do you think about itertools? The way I like to think about them is by shuffling things around and grouping everything. And once you get these 5 groups, the filtering, the complementary, the reshaping, the combinatorial, and the infinite itertools, then it's easier to think about whatever's happening. And then there's T in the corner, in the bottom right, but we'll take a look at T later. So for now, we're focusing on these 5 groups. All right, are you ready to dive into some of these tools?
Let's
Awesome.
go.
I like your enthusiasm. I appreciate it. Very well. Let's take a look at some of the combinatorial tools first. Now, the combinatorial tools, I like to start with them because, on the one hand, you can hopefully you'll understand them with a couple of examples that I think, or that I try to make as intuitive as possible, and also because the combinatorial tools have a kind of a mathematical flavor to it. So if you know anything of maths and you've heard the term combinatorics, then yes, there is a relationship here. Combinatorial iterables, they accept an iterable, and what they're going to do is they take your data and they combine the elements in different ways. That's the general description of the group. Now, talking about combinations and combinations with replacement specifically, let's see how they work. So in 2026, I'm thinking of visiting Germany, Czechia, and Austria. These are countries I would like to visit. And I'm representing them with their flags in the snippet of code. And now the question is, if I can only visit 2 of them, what countries could I visit? Like if I could only visit 2 of them, and at the end of the year you ask me, what countries did you visit? What different answers could I give? Well, I could say I visited Germany and Czechia, or Germany and Austria, or Czechia and Austria. Right? Do you understand is it making sense, the code and the answer? All right, this is what combinations does. Now, what if I said, hey, I have 2 days to spend abroad. Where could I spend these days? Well, I could spend 2 days in Germany, or I could spend 1 day in Germany and 1 in Czechia, or 1 in Germany and 1 in Austria, etc. So the combinations with replacement will also combine the flags I have, but this time I can repeat flags I already used. Any questions about this?
This is the best example I saw, which I can understand. So really nice. Thank you.
I appreciate it. I'll be honest with you, I have an even better example with ice cream flavors. So if I have a better example, why did I use the flags one? Because I wanted to try it out. But I'm glad you understood. All right, very well. So then what does permutations do? I like this one. Now let's take the same 3 countries, but now we're interested in knowing the order in which I'm going to visit them. And that's what permutations will do. You will take some countries and you will order the countries in all different ways they can be ordered. And in this case, there's 6 different orderings. So this represents the 6 ways in which I could say if I'm doing an interrail. Do you know what interrail is? An international term, right? It's, you've heard of it? I don't know. If I'm traveling by train, I'm going to visit all 3 countries by train. Like in which order is that going to happen? So these are the 6 different ways you can do it. And the built-in, not the built-in, but itertools.permutations also accepts a second argument, which is a number, which you can use to restrict the output to only ordering a smaller number of elements. So if I'm only visiting 2 countries, in what order could I visit them? Now I see something in the chat. Oh, okay, someone reacting to my mention of interrail. All right. Yeah?
How does this differ from the previous combinations?
Which ones?
The first example you showed in the previous slide, combinations.
All right, yeah. So how many for tuples with 2 elements? Note how there's 6 results. And if I scroll back quickly, give me a second. Combinations 2, there's only 3. Because in here, what I care about is the group as a whole. So Germany and Czechia, or Czechia and Germany, it's the same thing. So you can think of this as like a bag. If I come from the supermarket with a shopping bag, it doesn't matter if I first grab the milk and then the eggs, or the eggs and then the milk, because I'm going to have both. All right. And in permutations, order is important. Germany and then Czechia is different from Czechia and then Germany. I hope this clears things up. Yeah? Awesome. Any more questions about any of these 3 itertools? Very well. In that case, let's jump to the next group. Now, yes, I did skip product, because again, I don't want to overload you with 20. Let me just overload you with 12. It's already too much. So let's jump to the reshaping group. And the general idea of the reshaping group is that you take an iterable, you don't change the values that are being produced by the iterable, you just change the shape in which they are being produced. So let's see what this means. Let's start with batched. That was added in Python 3.12, I believe. What does batched do? Say you have a bunch of words and you want to process the words in groups of 4. Well, you use batched for that. So batched allows you to paginate or to group data from an iterable in batches of the size you specify. Now, quick question for you. I know it's not a question. Let's play a guessing game. The quick brown fox jumps over the lazy dog has 9 words, and I'm splitting the list of words into batches of 4. So what happens with the remaining word? Who wants to guess? Okay, so let's do...
What is
Sorry?
the remaining words? Because it will be creating, like the last batch would be over the lazy dog, so it will contain still all the words.
Okay, so the first batch is the quick brown fox. The second batch is jumps over the lazy. Now, do I get an error or do I get a group with just one word?
I hope you get one word.
Yes.
All right. Yeah, I do get one word. Now, this was just to see if you were awake. I mean, you were not supposed to guess correctly, or if you guessed wrong, I wouldn't be upset. Now, I raised my hand in Zoom, and I have no idea how to put it back down. So I guess we'll just have to live with that. Yeah. But in case... So if you're paginating, for example, API results, of course, it's okay to have a final page with a smaller number of results. But in case you expected the number of results to be neatly... to fit neatly into the groups, then you can set strict equals true, and if the last group has the wrong size, then you get the value error. But there's something very important here. Everything in itertools is lazy. It's the whole point of itertools is to allow you to work with lazy iterables, and for that to be possible, itertools or the itertools themselves, they are lazy. So if you're using batched with strict equals true, you only get the error when you get there. It's not a validation step at the beginning. It's an error at the end. If you get there, you might not even get there. Does this make sense? Awesome. So then let's take a quick look at iSlice. Who can guess what iSlice does? Don't be afraid, it's right in the name.
It checks if it is a slice of something.
Ah, interesting. No. It's not is slice. That's a very good guess, actually. It's I for iterator and then slice. So it will let you slice arbitrary iterables. Let's see what this means. Say you want to write a function called filehead that takes a file handle. So you've already opened the file with open as f, and you want to grab the first few lines. If this were a list, you would index with square brackets, right? Square brackets, colon 10, you get the first 10 elements. But you cannot do that with files. But you can use iSlice. So iSlice takes an iterable and a number, and you get the first n values of that iterable. This is just one pattern though. When you're slicing with square brackets, you can also specify a starting point, colon, and a stopping point. You can go from a position up to another position. So if you were writing a function, for example, that skips a CSV header in a CSV file, so you open the file, you know there's a header you don't care about, you essentially want to skip the first item. Yeah? if you're using square brackets to slice a list, you could do square brackets 1:, and that's going to skip the first element. But with file handles, you cannot use square brackets to index, so you can use islice. You can say islice the file handle 1, so skip the first one, and then comma none. And the none here means just go until whenever. Yeah. Awesome. It's much easier when you... I'm glad it's making sense. All right. So the next one, I really like this next one. Group by. Are there any pandas users in here? Or actually polars users for that matter? Pandas or polars users? No one? No, that's fine, because it actually makes it easier to explain this. So yeah, because you have no preconceived idea of what this should do. So group by, how does this work? Very interesting. So you have an iterable that's starting on the left, and then we don't care for how long it goes. You have an iterable. And then you have a function, let's call it a key function, that takes a value and returns a key for each value. So you're going to take that key function and you're going to apply it to all of to the whole iterable. And let's say that the color and the letter here represent the the result of that key. So the first two elements were pink or magenta, and then the next three are blue, and then the next one is again pink or magenta, and the next four are orange and whatever. So you take the key, you apply it to all of the iterables, and then group by will return the groups by the key. So it's not sorting the whole thing, it's going to produce the consecutive runs of elements that share the same key. So first you get the 2 pink, and then the 3 blue, and then the next pink, and then the 4 orange, and then whatever comes next. Any questions about group by? Alright, so I only explained the idea. The return value of group by is slightly more involved than this. Because it's lazy, there's all sorts of interesting implications. Like the group itself, you don't have it eagerly. This kind of looks like maybe a list with all of the elements. That's not the case. Group by will return something lazy that you can look into eventually, but it's lazy. But the idea is this. It's going to give you the consecutive groups under the key. And this function key, if it didn't click, then take a look at the built-in sorted, for example, or the built-ins max and min, which also take this key function. So that's a good idea. If you understand sorted with a custom key, then group by, the key in group by has a similar vibe to it. Great. We took a look at a couple of reshaping itertools. Now let's take a look at the filtering ones. And hopefully you can already kind of guess what's going to happen. We're going to be filtering data. But don't worry, I'm going to spell it out for you folks. So there's take while and drop while. And I'm showing them together because guess what? They're kind of related. So let's say you have again an iterable. And you're going to take a predicate function. So a predicate function is a function that accepts a value and returns a boolean. So you get to ask a question about each value, and then this returns a result. It returns an answer. So you take the predicate, you're applying it to your iterable, and essentially you get the key. For some values the predicate is true, and for some values the predicate is false. Do you understand what I mean by applying the predicate and getting the trues and the falses? Which part is not clear to you, Diederik?
What data am I putting into this function?
Whatever's inside your original iterable.
It's like
Don't I need like what is going to be green and what is going to be red? Don't I need some kind of filter?
What I okay, I think I understood your question. So originally I have whatever values. It could be, let's say, I have numbers, and then my predicate is even. So I'm checking which numbers are even or odd. And when I apply the predicate, I get trues for the first three numbers because the first three were even, and then I get two falses because I have two odd numbers. So the green and the red, or the T and the F, already represent the results. Does that help?
Yeah, I think so. I mean, the is even was missing from the previous example, so I kind of lost the.
Oh, right. Okay, yeah.
my train
Sorry.
of thought.
So this is just supposed to be a generic representation of an arbitrary predicate applied to an arbitrary iterable. So this might be what I get. And now we see what take while does. So if you run take while with your original iterable and the predicate, you would get elements as long as the predicate is true. So in this case, you get the first three elements. You don't get the fourth one because the fourth one is already false. So take while would return the 3. Whereas if you do drop while, who can guess what I get as a result?
Only red?
Interesting. You're close. The thing is, note how take while doesn't give me all of the green ones. There's T5, 6, and 7. I don't get those. So I only take. So take while is also take until false, kind of but until I hit a false one. So I don't care about what comes next. Drop while is similar. So I drop while I'm looking at greens. So I'm going to skip the first 3, and then I get everything else. Now there's something very important here that might be misleading from the diagrams. This is just a representation of what will eventually be the result. When I'm applying take while or drop while, or filter, the built-in filter for that matter, I don't eagerly compute the predicate. I don't start by running the predicate through the whole iterable. Everything is happening on the go. Alright? I only apply the predicate to the first element when I need it, and then to the second element when I need it, if I need it. Does that make sense? Okay, because this is a very important distinction. Awesome. This is take while and drop while, and the reason I really like them is because they're complementary. Whatever take while gives you is what drop while will ignore. Alright. Now let's take a look at compress. I'll be completely honest with you, I think this is super cool and also super useless. I've never been able to... One of the things I do, I teach Python, I write a lot about Python, I teach Python, and when I'm teaching stuff, I need to give practical examples, right? Otherwise people won't understand the point, they won't understand how things work. I have a decent diagram for this, but I've never been able to use this in real life. But I'll show it to you either way, because I spent a lot of time working on the diagram. So I have an iterable with some data. Now for some reason I have V's instead of ellipses. But that's what we have. And now what I'll do is, I'll say that for some reason I also have a second iterable that I'm going to call selectors that has Boolean flags. I got them from some data source, I don't know. Diederik gave them to me. And so I have some trues and some falses, and now what I do is, by using compress, I can compress the data with those selectors and get only the values for which the selector is true.
I have a question.
Yeah.
What kind of scenarios we need this thing, like in real life?
That's what I said I don't really have. So
Okay.
if you look at it, this is very similar to filter. But with filter, with the built-in filter, you have the predicate function and you're computing the predicate on the fly. If you already have the predicate applied, if you have, I don't know, from some API you can get the flags already, the predicate pre-applied for some reason, then you can use compress directly. This would be slightly more convenient than doing something like zipping the data and the selectors and using an if. So I guess this is a good time to say that everything we're looking at, the itertools we already saw, the itertools I'll show you, and the ones we're not mentioning, they don't do anything. So they do not do anything you can't do with the Python you know already. Okay, I'm not showing you new syntax. I'm not introducing something groundbreaking. I'm showing you tools that make it more convenient to work in iterables in their specific scenarios. Now, are you going to use compress a lot? Well, if you are, email me. I don't think so. But the point is, I want you to, again, be aware of the things you can do. Yeah, that's it. So there are, for all of the tools, there are workarounds, there are different ways of getting there with for loops and generators and everything. These are just the convenience tools you get to use. So Kushal, I don't have a satisfying answer.
Good enough. That's good enough.
Okay. All right. Let's take a look at the infinite group, and we're almost done. After the infinite group, there's the complementary group, and then that's it. I really like the infinite group because it generates infinite streams of data. And like I said, I have a maths background, so infinity is kind of neat. But in practice, you never want infinite streams of data. You're always using these in conjunction with something else. All right? Otherwise, your program is going to run forever. So what does cycle do? Well, it's right there in the name. If you have something like a list of possible outcomes, I picked up a flower, I want to check if my fiancé loves me or not. I'm going to play the game of you take a petal out, she loves me, I take a petal out, she loves me not. If I do this, I only get to print, or I only get to take 2 petals out. So what I need is I need to cycle through the possible outcomes. So if I add a cycle, then this keeps going forever. As I said, this is going to keep running forever. It doesn't end, so you need to use this in conjunction with something else. For example, if I were working with a petal, with a flower and the petals, I could zip this cycle with the petals so that I'm pairing each outcome that's being repeated with a petal, for example. Or I could use islice to only get as many outcomes as I need. Make sense? Brilliant. Oh wow. Did you see the fireworks? Let's see if I can I what did I do? Or was it the thumbs up? I don't know. Okay. It's technology, right?
Yes, it's on the Zoom, so yeah, I think double thumbs up has a lot of fireworks. This time
Okay,
it's
sorry.
not.
Sorry, let me not waste your time. All right. So then let's go to the complementary tools. Now I'll share a little secret with you. I'm not saying I'm the only person who thought about this, but I created this categorization by myself, so independently, right? And I created the 4 groups we already looked at, and then I was left with accumulate, star map, and zip longest. And I thought, now what the heck am I going to call this group? What do I do with these 3 things? And then I realized, wait, these are actually tools that are complementary to something else in the language. So this I thought was going to be a miscellaneous group, but there's actually also something interesting going on here. Let's see. By the way, quick guessing game. Who can guess, if you take a look at zip longest, what is zip longest related to?
Between, oh, that's the longest.
In the built-in, sorry, so it's not one of the other 18. Zip longest is related to what built-in?
Zip?
Yeah, and star map, oh boy, I already spoiled it. Star map is related to what built-in?
Map?
Yes, don't be afraid, come on folks. Yes, and then accumulate isn't so obvious, so we'll take a look at that now. So accumulate versus reduce. If you sum a list with the number 1, hopefully you're not surprised when I say that the result is 1. If you sum a list with a 1 and a 2, you get a 3. If you sum a list with a 1, a 2, and a 3, you get a 6. If you sum a list with a 1, a 3, and a 4, a 1, a 2, a 3, and a 4, you get a 10. The built-in sum takes something like a list and it sums everything. But it only gives you the final result. If you wanted the partial results, or the intermediate results, or the running totals, whatever you want to call them, you use accumulate. So the partial results you got, that's what accumulate gives you.
Nice.
It gets nicer. It gets nicer. Because sum, the built-in sum, is just a very special case, a very common case, but it's a special case of using the built-in. Sorry, it's no longer a built-in, but it's a special case of using reduce from the module functools. It's reducing with addition. By the way, I'm cheating in the slides because you can't use the plus operator like this, but you could import it from the module operator, for example. But just a visual representation, a reduction of the plus and the least gives you the results you have on the screen. But the plus is just one operation. You can change the operation to multiplication, for example. And now you have the 4 results at the top. These are all products, the final products, but the partial results with accumulate. Sorry, but accumulate still gives you the partial results. Wait, before I skip to the next slide. Do you understand this? Does this make sense? All right, awesome. And by the way, I've cured it now, but I used to be obsessed with reduce as well, because there's like 6 or 7 built-ins that are actually reductions. So think about it. All right, and I keep lying to you. I do it on purpose, but not because I'm mean. This isn't strictly true. This is not an equality. Because, again, everything in itertools is lazy. So accumulate is lazy as well. If you want the least, you need to get it out of accumulate. Otherwise, you just get a lazy iterable. All right. Any questions about accumulate? Great. So then let's take a look at star map. Say you have a function that takes 2 arguments. I have the first argument, I called it A in red, and the second one B in blue, because I'm going to lean on the visual aspect of things to help me put across the way star map works. But first, let's take a look at map. So assume you have an iterable of A's and an iterable of B's. If you want to apply F to corresponding pairs of A's and B's, you can just use the plain map. The built-in map takes a function, however many iterables you want, and then it's going to call the function on those elements. So this is what the built-in map computes. F of A0, B0, F of A1, B1, etc. Is everyone comfortable with this diagram? All right. So map will do this. Now, instead of thinking about map with the function, let's just think about zipping the 2 iterables together to create the pairs, the corresponding pairs. If you zip them together, you get an iterable of A0, B0, A1, B1, etc. So if you had the zipped data, if you had pairs of arguments you want to pass to the function, how do you do that? Because if you map f, the function f, on this data, you get the wrong call, because you're calling f on the pair. And you're not supposed to call f on the pair, you're supposed to call f on the 2 arguments inside the pair. So you would need a star. You would need to unpack the pair. Wait, but weren't we talking about star something? That's what star map does. If you take star map f and a piece of data, then the function gets applied to the unpacking of the pairs. Or they don't need to be pairs, they're going to be tuples of data.
Nice.
From your reactions, I can see it was totally worth it spending. I'm not going to tell you how much time I spent creating this diagram, but from your reactions, worth it. Questions about map or star map?
I think just I want to repeat that this kind of visualization is really helpful to understand and very clearly.
I'm really happy to hear that. Thank you. Well, folks, all good things come to an end, and we're getting close to the end. We just didn't mention T, which I left there in the corner. So let's talk about T. Or maybe let's do it next time. Because T is... out of the 20 objects in itertools, all of the other 19 are lazy iterables. T is a function. And what is more, T as a function seems to defy the laws that govern the way generators and lazy iterables are supposed to work. So you could make a whole talk on T itself. So that's why I skipped it, and that's why I'll spare you from hearing about it for now. It's a super interesting function though, but it's also kind of a niche thing, so yeah. So then the final question remains. No, it doesn't. I'm skipping ahead my own slides. This is a quick overview of the tools we talked about. There's 12 of them. It kind of hurts that we almost looked at all of the filtering, complementary, and combinatorial ones, but the groups are so small that, yeah, I would always need to leave one or two out. And there's 7 iterables we didn't take a look at. And to be completely transparent, my 3 favorite iterables from itertools, they're all in here. Product, chain, and pairwise are my top 3, and we didn't talk about them. So there's lots of interesting things you could still learn about itertools. Also, some of the things I talked about, I didn't talk about all of the optional arguments or all of the edge cases, so it's not like I taught you everything. Lots to learn. And now, yes, the final question is, how do you take these tools, these iterables, and how do you use them efficiently, effectively? How do you use them to write good code? And the only way I know, if you know a different way, let me know, but the only way I know is to first go and write bad code. So you need to take what you learn, you need to try and apply it. You're eventually going to make a mess, you're going to write code that kind of looks bad or that you don't really like, but it's through that process that you learn when, how, where to use these tools. Whenever I learn a new module or a new function or a new piece of syntax, I think about it and I try to come up with all of these different scenarios in which I could try to use it. And I always end up writing code that looks terrible. But among those terrible experiments, there's also good experiments. So that's how I figure out how to use things. So this is one way to do it. It's the way I know, and it's a suggestion I give to you folks. All right. I really appreciate the fact that you bared with me for so long. I have on the screen a QR code that's going to take you to my newsletter in case you're interested in getting a Python deep dive every Monday. Like I said, I spend way too much time thinking about Python, writing about Python. And if you have any leftover questions or any comments, I will be happy to chat with you. Thanks, folks.
Thank you. I have a question in general, Rodrigo. So my use cases of itertools, or like the other one which you did not mention here is functools,
Yep.
are related more about like not the daily use cases, but like separate places where I thought like, oh, like the way functional programming works or that idea of thinking, these things really makes sense where I have a lot of data and I'm just like, oh, I need to do something like transform the data in somewhere and then keep like joining things together and then have the output where the actual thing is much bigger than just doing it in a normal for loop and do the things. But where do you think or where do you see people using itertools, for example, in, let's say, projects which are not to do with data directly, or like not data sciencey projects, but normal other Python projects.
All right. Okay, so there's another accurate statement that's kind of not very useful is whenever you're working with generators, itertools are useful, but that's kind of a blanket statement. Now, a very, very concrete example, when you're writing tests for any regular Python projects, when you're writing tests, when you're writing parameterizations, you can use itertools.product, which is something we didn't cover, to generate more tests for you. For example, just to make it a bit more concrete, if you have a function that takes an integer and a string, you can write down some strings, you can write down some integers, and then you use itertools.product to combine all of them together, and you pass all of those different test cases to your function, for example.
Thanks. That's a very clear example.
Awesome.
Questions?